Hey everyone, Mrs. Ragstad here. I'm excited to jump into lesson 6-2 with you on chemical symbol rules, and these will be very useful as we continue our study in chemistry. So you're going to be taking notes, and again, you need to use Rocketbook formation to label each page of your notes. So we need to do hashtag L6-2 notes, your name first and last, and then two more hashtags, and that will be at the top of every page that you take in your notebook. And remember, these notes that you take for these videos must be handwritten because studies show that handwriting notes helps you to remember it in a much more profound way. All right, so our objectives for today are that you're going to learn to be able to recognize element symbols from their names and vice versa, and you're going to be able to explain the rules for capitalizing and other ways that we determine chemical symbols. So here is a picture of the periodic table, and you'll see that for each square, each one represents an element or a type of atom. There is a full name of that element. For example, here we have boron, and then there's also an abbreviated symbol. So the symbol for boron is capital B, and these symbols are really important because when we start to write chemical formulas, when we start to put these elements together, then it is too tedious and too difficult to write out the entire name of that element when we're putting it together. So you might know H2O as the symbol for water. Well, this means that there are two hydrogens and one oxygen. So it would be too much trouble to write out hydrogen, hydrogen, oxygen every time we wanted to talk about water. All right, so in this video, I will show you the rules for determining what those symbols are and how they work. All right, so the first rule is that all chemical symbols must have one capital letter. Okay, one and only one. No more than one. I'll write that here. And only one capital letter. So for example, here are some chemical symbols, and you can see this here. So H, capital H for hydrogen, He for helium. Notice only one of these letters is capitalized. Li for lithium. Notice only the L is capitalized. And B for boron. So in each of these, the first letter has to be capitalized. Symbols have one capital letter, and it is the first letter. Now, in some cases, that's all you need. For example, for boron and hydrogen, there's no more letters in the symbol. But if the chemical symbol needs a second letter, because, say, for example, hydrogen and helium both start with the letter H, so helium needs a second letter to distinguish it from hydrogen. If it needs that second letter must be lowercase. So here are some examples where there are two letters involved: silicon, calcium, and chlorine. Now, when I write chlorine, I like to use this cursive kind of L. When you see it in print, it will often look like this, and it's easy to confuse the lowercase l with an uppercase I. When in doubt, assume it is a lowercase l because chlorine is a very common element. And that would be a good assumption to make. All right. Now, how do we determine which letter becomes the symbol for a chemical element? So if it's possible, and in some cases it is possible, we would just use the capital letter that the element begins with. So for hydrogen, oxygen, nitrogen, fluorine, and carbon, that works out really nicely. So these are all capital letters that I've written right here. However, in the cases of these elements, the first letters have already been taken by the elements up above. So we have helium. We add a lowercase letter to the uppercase letter: oganesson, nickel, and calcium. Now, in some cases, that's not even enough. And in those cases, we resort to the Latin name. It so turns out that many elements on the periodic table have been known since ancient times, many thousands of years. For example, silver is mentioned in the Bible as Judas betraying Jesus for 30 pieces of silver. So these elements were known and used, and therefore they have Latin names because during the Roman Empire, Latin is the language that they spoke. So scientists today have used this to our advantage so that we have more symbols to draw from when the English letters have been taken up by other elements. So these are the symbols for these Latin-based elements. So we have Na for sodium, based on the Latin natrium, Au for gold, Ag for silver, Fe for iron, Pb for lead, Hg for mercury, and K for potassium. So those are ones you're going to write down and try to remember because they show up a lot, and it'll be easy to get confused if you're not familiar with the fact that these ones are based on Latin names. Okay, now what about new elements? So I mentioned in the last video that some of the elements on the periodic table were not present on the poster in my classroom, specifically this row right here. Okay, so how did we get these new elements? And the question, or the answer to that, is that scientists basically made them. They are man-made elements. Up here, this is what's called a particle accelerator. And right here we have an aerial view of one. You can see they go on for miles in underground tunnels, and these are what the tunnels look like from the inside up close. And in these tunnels, scientists are able to bombard protons and neutrons and electrons towards one another near the speed of light. And sometimes they are able to do so in such a way that a new element forms. And usually the element only exists for a fraction of a second. But if scientists are able to detect it, as in the case of these new elements down here, then they publish it in a paper and they get to have a new name. So all these are man-made. They were not discovered in nature, but it's really cool that human beings have been able to put these together by accelerating particles near the speed of light. Okay, and here is a previous version of the periodic table where some of those man-made elements had temporary names, and you'll see these names also on my version of the periodic table on the wall. And since these temporary names were there, it's called the IUPAC, and that's the International Union of Pure and Applied Chemistry, which is a fancy committee that comes together and decides on new names. And some of these names are named after famous scientists. For example, Mendeleev, right here, got an element named after him, Mendelevium. Alfred Nobel, who the Nobel Prize is based on, he has an element named after him. There's one named after Einstein. There's one named after Marie Curie. And so that's one of the highest honors that a scientist can have, is to have an element on the periodic table named after them. All right, that's all I have. See you in the next video.